Okay, my name's Ben, and I've kind of been here forever, like 10 years now. But I want to show you guys something that's kind of fun. Normally I do kind of defense stuff in security, but I've wanted to do something offensive for a long time. And so this is my chance to, one, kind of learn some low-level stuff in Java, and then two, just do something kind of evil. And it's right around Halloween. Halloween's tomorrow, so I thought this would be a good topic to mess with. So who's ever done some Java work? Like, okay, cool. Yeah, so a lot of people. So we're going to make an evil version of Java. And we'll do that with Managed Code Rootkits. So Managed Code or something like Java or Python. They're all things that kind of run inside this virtual machine. Whereas unmanaged code would be like C or C++. Um, that are compiled directly and they run. They're compiled directly to machine code and they run directly on the machine. But C# is a managed language too. So I mean, it kind of come in two different categories. And eventually we'll come to this tool that I've built that kind of makes it really easy to write these. And we'll demo the tool. We'll actually create a rootkit, and then you guys get pizza. So that's awesome. All right, so I mean, everyone's kind of written this program, right? If you've written Java, it's probably the first program you wrote. And if you ran it, it should just print out "Hello World," right? So let's do that. And so I'm going to go ahead and we'll just run it with a regular old Java, and it prints out "Hello World." Cool, right? Just as we expect. But if we run it with a version of Java that's been changed, who knows what's going to happen, right? So this one, it just prints out "Hello World" backwards, right? So nothing too exciting except that it's not what you expected, right? And so nothing was changed about this program. This would print out, any Java program that would run on this machine would print out everything backwards, right? So it's nothing wrong with the program. It's something wrong with Java itself, right? And so let's take a look at how Java would work at a lower level. So normally we start with our Hello World program, or whatever our program is in our Java code. We write our Java source and the Java files, and then we hand over all those Java files to the Java compiler. And the compiler spits out all these .class files. So this is all the Java bytecode, and we get one or more of these class files for each Java file that we wrote. And sometimes we even just zip up all these jar files into just a zip file. And because we're Java and we're fancy, we rename .zip to .jar. And that's how we pass around our Java programs, right? And these jar files, when you execute them, they can run on Windows, Mac, or Linux. It doesn't, we didn't create a new version of each program for each operating system or each architecture, ARM or Intel or AMD or whatever. Right? We only made one Java program, and it's somehow compatible on all of these. Whereas C or C++, you would have to write a different version of the program for each operating system, which is kind of a pain, right? And Java has this compatibility feature that they like to call write once, run anywhere. And the way that they do this is by creating a Java virtual machine, or a virtual machine that basically will take your Java program and translate it into the machine instructions for each of the operating systems or each of the platforms that you're running on. And if you look inside the virtual machine, you also get some of these runtime libraries. So the runtime libraries include things like the string, or the way, common ways to sort arrays, or the way we connect to the internet, just kind of the built-in, parts of Java that we kind of get for free. It comes with Java. And so what we're going to do is actually replace those runtime libraries with something a little bit different, right? And so there's a couple ways we could approach this problem. How do we want to do that? So we could try to just edit those class files directly, right? We could edit the bytecode directly, which would work, but it's pretty difficult. And the reason is because there's kind of this butterfly effect. Say you change the name of a variable or a method. You then would have to go through the rest of the program and change it to be, to match, right? Or if we, add something to a method to have like more parameters, we have this kind of stack size, right, that we have to recompute, and all these kind of things have to get recomputed with each change, which is kind of a pain. Totally works, but kind of a pain. We can go a little bit more abstract, and there's been a lot of research into these things called intermediate representations or intermediate languages. And this is something that's not quite Java source, but it's not quite bytecode either. It's something in between. And this works It allows us to decompile the bytecode, make some changes, and then recompile it back to the bytecode. But as developers, nobody really studies intermediate representations from a development point of view, because there's no point. If you want to develop new class file or new bytecode, you just start from source and let the compiler do the work, right? Nobody really comes backwards unless you're trying to do something researchy or kind of evil, right? So ideally, we would like to work from source code, because this is still a little tricky. It's a little alien and unfamiliar to us. So we'd like to work from source code, but in order to get to the source code, we would have to somehow decompile the bytecode and then get the source code. And there's tools to do that, but they're pretty unreliable. And that's because this is actually a pretty hard problem. That's why people try to go to the intermediate representation instead, because we can't go all the way to source. And most of the time, you just get a bunch of garbage. So this doesn't always work. But ideally, we'd like to work from source level, right? And the problem with all of these approaches is that the runtime libraries, since they're included with the Java virtual machine, don't have that write once, run anywhere property. They come with the virtual machine, so they're a little bit different for each deployment of Java. So we don't want to have to do that either. We want all the benefits of Java, even though we're trying to destroy it at the same time, right? So anyway, this is where this tool that I've been building comes in. And it allows us to develop and even debug those changes to the runtime libraries inside Eclipse, an environment that we're familiar with. And allows us specifically to write new source code, which will then either get inserted into Java, replacing logic in Java, or merging logic in Java. And the merge is kind of important because a lot of times we don't want to just completely replace it. We want to merge it in because Java kind of depends on itself. So if we replace something, we might break something else. So if we can preserve the behavior but change just kind of the way that the user interacts with it, that's even better. So that's this tool supports all three of those. And since we're starting from the source code level, we get that write once, run anywhere property back, which I'm going to call a write once exploit anywhere, which I think is pretty important if we're going to do this efficiently. So let's do a demonstration, and let's develop a modification for the runtime library that will hide a file from any Java program, and just one file specifically. Doesn't matter if it exists or not, but I want to hide it if it does. Okay, so first let's write a little bit of test code and kind of figure out how we're going to develop this. So I'm going to create a new file. I want to just call the file secret file. And then just to make sure that it actually exists, I'm going to just write a string to it. I'm just going to write blah and save the file, right? And then I'll print out true or false if the file exists. And there's an exists method on file that returns true or false if a file exists. And at the end, just to kind of clean things up, I'm going to delete the file again. So if we run this with regular Java, it should say secret file exists, true, right? Because we wrote to the file, it does exist. So now let's develop our attack code. Okay, so I'm creating a new class in Java. And Java's object-oriented, so it allows us to create new objects and also inherit functionality from the things that you're extending. So I'm going to extend the original implementation of file, and I get some stuff for free. Now right away, Eclipse is already doing some of our job for us, which is great. Because we're at source code, we can use all these tools again, right? So I'm going to add a constructor because there's an error. If I extend file doesn't have a default constructor, so we have to make one. So I'm going to let Eclipse just write that code for me. And then just to keep things clean, I'll rename the variable names here quick. Cool. And now I want to get to the method that we want to change the behavior of. So I'm going to change the behavior of the exists method. And I'll just return false here. So right now, this would just really mess up things, right? This is going to say all files don't exist, including the program that I am, right? So that would really kind of mess things up. But I'm also going to use a nice little feature here. This is called an annotation. Yeah, override. So this is going to check, annotation is just kind of a note to either your development environment or the compiler that I want to do something. So I want to say, make the check that this method is actually overriding the file version of this method. So if I had, like, say, a typo, it would tell me, right? So this is just a nice little feature. And I didn't make this. This comes with, Eclipse in Java. And so let's go ahead and change, let's write how we want this method to behave. So I'm going to say if the file is actually a file, because it could also be a directory, we don't know at this point, and isFile comes with the file class. So we get this method for free. So if it's a file and the name, we can check the name with getName, and if the name equals secret file, then I'm just going to go ahead and return false right away. Doesn't matter if the file actually exists, let's just return false. Otherwise, I just want the default behavior of file, right? So I'm going to use the super keyword. Super allows me to call my parent's implementation. So the original file's implementation of exists. So I'm going to just return, true or false whether the file actually exists in all other cases. Okay, so now I need to somehow denote a way for my tool, for this JRE frameworker tool, to make these modifications. And just like the override, I'm going to use some annotations to define how I want to merge this into the runtime environment. So I have some annotations that we defined. So I'm going to say I want to do a merge because I'm still depending on the original implementation of exists, so I don't want to totally replace it. So I'm going to merge this, and I don't care about this method. This is just kind of, locally, I don't actually need to merge this into file, but for my subclass, I do need it for my development. But I do want to merge this method in. So I'm going to say merge method. And that's all we have to do as a developer point of view. The rest, the tool will take care of for us. This is an Eclipse plugin, and we integrate directly into the build environment. So all I have to do is build my project, and it will generate a new runtime jar for us. So, okay. All right, so it's generated our new runtime jar. So at this point, I'm going to test it inside Eclipse because that's, it's nice and easy. And if there's a bug, I can fix it right away. But as an attacker, all I would have to do is make these changes to the victim's machine, right? And if this was my, if I want to do this to my machine, all I have to do is go find my Java's version of runtime.jar and replace it with this version, right? So on Windows, that's in C, program files, Java, the 7 for your Java 7. And then libraries rt.jar, right? So I just swap them out, and I would get this modified behavior. But let's go back and let's just make sure it works. So I'm going to run it using the modified version of the Java library this time, and now the file does not exist, even though we know that it does. We wrote to it, right? So any Java program that would run would never see this secret file. So if I had a file browser, I just wouldn't see it, right? Okay, so we can do all sorts of things with this now, and since we're working from the source code level, we have much more kind of creative freedom versus if we, were at the bytecode level, it would take a lot more work to do something. So here's one that I recently developed, and so this overrides the key event class in Java. And so key event is basically when a keyboard event happens, it creates an object in Java, but since I'm overriding it, I get first dibs on what that event is going to do, right? So what I did was I created a spell checker, and then I inverted the logic, right? So what do I get? I get a spell wrecker, something that creates typos. And I monitor how fast you're typing, how many key events are getting generated, and the faster you type, you can see when it turns red, I insert a typo, right? But then as you slow down, because you're making all these mistakes, you slow down to try to okay, you're just typing too fast, they start behaving again, right? And so this is kind of evil, and it's just trying to basically mess up your productivity, right? And just kind of slow you down. So if you think about the things you would type fast, like your passwords, right? All of a sudden you would just never be typing them, right? Until you slow down, if you go nice and slow, it all works, right? I just don't want you to be very productive, right? So we can imagine all sorts of places we would embed this stuff. But one thing to note is I'm not going to be able to do this to you unless I have administrator control of your machine, if I have root on your machine, right? And this is because the Java runtime libraries are installed in administrator directories that protect it. So if you run a program and it pops up and says, this program requests to be run as administrator, think about the things that I could be doing, right? Or the things that that program could be doing. Or, if your operating system gets compromised or someone finds another way to compromise your machine, all these things are now opening the doors for this sort of attack, right? We can really start to mess with things from here on out. Okay, so that's all. If you guys have any questions, I'm happy to stick around. But enjoy your pizza. Oh yeah, and the tool's open source. You can play with it. It's just an Eclipse plugin. If you go to benholland.com, you can get to the tool and download it. There's tutorials and stuff too. So yeah.